In 1941, German U-boat captains called British radar the Magic Eye, but they weren't afraid of it. They were right not to be, until a piece of technology the size of a shoebox changed the entire war. For 2 years, the Atlantic belonged to the German U-boats, and Britain was starving. But the difference between total defeat and eventual victory wasn't a battleship, it was a math problem. The German High Command knew about Allied radar, and they laughed at it. They believed their U-boats were invisible. What they didn't know was that their own scientists had missed the one discovery that would cost them the war. In the darkest, earliest days of the Second World War, the fate of Great Britain, and perhaps all of free Europe, didn't hang on the courage of its soldiers or the quality of its tanks. It hung, quite literally, by a thread, a lifeline of merchant ships stretching 3,000 miles across the cold, brutal North Atlantic. This was the convoy system, the artery that pumped lifeblood from America and Canada into a besieged island, food, fuel, steel, and the guns to fight back. But this artery was bleeding, hemorrhaging ships and men at a rate that Winston Churchill himself would later confess was the only thing that truly frightened him during the war. The culprit was a silent, unseen predator, the German U-boat. And for 2 long, terrible years, from 1940 to 1942, the U-boat crews were winning. They called this period Die glückliche Zeit, the happy time. It was a time of feasting for the wolfpacks and a time of absolute terror for the men of the merchant navy. Their tactics, perfected by Admiral Karl Dönitz, were brutally effective. Dönitz, a hardened veteran of the First Great War's submarine service, despised the old thinking of lone wolf attacks. He envisioned a pack. His U-boats would spread out in long patrol lines across the convoy routes. When one boat spotted the smoke plumes of a convoy, it wouldn't attack, not right away. It would shadow the convoy, just over the horizon, and begin transmitting coded signals. These signals, picked up by other U-boats, would call the pack together. They would gather, often over a day or more, maneuvering ahead of the slow-moving merchants, and then they would strike. They wouldn't strike in the day, when the sharp-eyed lookouts on the destroyer escorts might spot the feather wake of a periscope. No, they would attack at night on the surface. This was their deadliest trick. A surfaced U-boat was low in the water, a needle in a haystack, presenting a tiny silhouette against the churning black waves. They could move faster on their diesel engines than the merchant ships, and almost as fast as the corvettes and destroyers protecting them. They would slip inside the protective screen of warships, unleash a fan of torpedoes into the packed columns of freighters, and then crash dive into the depths, leaving chaos behind. For the Allied sailors, it was a nightmare. A ship weighing 10,000 tons would simply vanish in a flash of orange fire and a deafening roar. In the darkness, men scrambled for lifeboats, often finding only burning oil and icy water. The escorts, meanwhile, would race toward the attacker, their sonar, or ASDIC as the British called it, pinging desperately into the abyss. But the U-boat was often already gone, slipping away to hunt again. The Admiralty was desperate. They knew they were losing the tonnage war. For every ship they built, the U-boats were sinking 2, sometimes 3. The entire war effort was at risk of starvation. If the convoys couldn't get through, Britain would have to sue for peace. It was as simple and as stark as that. The problem was one of detection. How do you fight an enemy you cannot see? The surface escorts, the destroyers and corvettes, were brave, but they were half-blind. Their ASDIC was a marvelous invention, sending a sound wave through the water that would bounce off a submerged object, revealing its bearing and range. But it had a fatal flaw. It could only find U-boats that were under the water. It was completely useless against a surfaced U-boat charging in the dark. And that was precisely when the wolfpacks did their killing. The other tool they had was radio intelligence. At places like Bletchley Park, brilliant men and women were working day and night to crack the German Enigma codes. When they succeeded, it was a godsend. They could read Donitz's orders to his wolfpacks, pinpointing their patrol lines and allowing the Admiralty to reroute convoys around the danger. But this intelligence was fragile. The Germans changed their codes monthly, sometimes daily. A new code book, a new setting on the Enigma machine, and the Allies would be plunged back into blindness, sometimes for weeks on end. During these blackouts, the U-boats would feast, and the losses would climb to agonizing new heights. The Allies knew they couldn't rely on code breaking alone. It was a temporary advantage, not a permanent solution. They needed something else. They needed a way to see in the dark.
The answer, they believed, was radar. The British, in their desperate wizard war, had been pioneers in this new science. They called it RDF, or radio direction finding. It was their radar network, Chain Home, that had saved the RAF during the Battle of Britain, allowing their Spitfire pilots to meet the Luftwaffe formations before they reached their targets. It was a war-winning technology, so naturally they tried to put it on their ships and planes. The primary set used by RAF Coastal Command aircraft was called ASV Mark II, for air-to-surface vessel. And it seemed like the perfect weapon. A long-range patrol plane, like a Sunderland flying boat or a B-24 Liberator, could fly over the vast, empty ocean. Its ASV set pulsing radio waves into the darkness below. When those waves hit a surfaced U-boat, an echo would return, painting a small blip on the operator's screen. The plane could then home in on the blip, drop its depth charges, and send the predator to the bottom. In theory, it was brilliant. In practice, it had a massive, unexpected flaw. The ASV Mark II radar operated on a wavelength of about 1.5 meters. This was, at the time, a high frequency, but it required a rather large and clumsy antenna array, looking like a forest of metal poles on the wings and fuselage of the aircraft. It could, under good conditions, detect a surfaced U-boat from several miles away. But the Germans were not stupid. Their U-boat crews began reporting strange, sudden attacks by aircraft that seemed to appear from nowhere, even on cloudy nights. German intelligence quickly deduced that the Allies were using some new form of detection, and so they built a counter. It was a simple device, a wooden frame with wires, often called the Cross of Biscay because of where it was most used. The U-boat crews would mount this crude-looking antenna on their conning towers. This device was a radar detector. It was a receiver tuned specifically to the 1.5-meter wavelength of the Allied ASV radar. The Germans called it Metox, named after its French manufacturer. And it completely, disastrously turned the tables on the Allies. The U-boat now had ears. The Metox receiver was far more sensitive than the radar itself. It could pick up the probing pulses of an Allied aircraft from 30 or 40 miles away, long before the aircraft's radar could get a return echo from the U-boat's small conning tower. The German radar operator would hear a telltale beep, beep, beep in his headphones, and the U-boat captain would know with certainty that a hunter was nearby. This is where the mockery began. The U-boat captains, far from being afraid of the magic eye, now used it as their own personal lookout. The Metox gave them perfect warning. The moment they heard the pulse, the captain would shout alarm, and the U-boat would crash dive into the safety of the depths long before the Allied plane could ever see it. The pilots of Coastal Command grew increasingly frustrated. They would fly for 8, 10, 12 hours over the freezing Atlantic, their radar screens empty. Or worse, They would get a faint contact, race towards it, only to find an empty patch of ocean. The blip had vanished. The U-boat was gone. The Germans grew arrogant. They felt they had beaten the magic eye. They referred to the Allied radar as a clumsy, idiotic tool that only served to warn them of danger. They were invisible. They were invincible. And the happy time, it seemed, would last forever. But while the U-boat crews were laughing, a very different kind of war was being fought in secret, in quiet university laboratories, far from the ocean. This was a war of physicists, engineers, and mathematicians, and they were working on a problem that the Germans had already dismissed as impossible. The core of the issue was the 1.5-meter wavelength. To get a sharp, focused beam of radar, a beam tight enough to spot a small object like a periscope or to paint a clear picture of a target, you needed an antenna many, many times larger than the wavelength. With a 1.5-meter wave, you would need an antenna 50 feet across to get that kind of resolution. This was fine for the giant chain-home towers on the English coast, but it was completely impossible to mount on an aircraft, let alone fit inside the cramped hull of a destroyer. What the Allies needed desperately was a way to generate radar waves that were shorter, much shorter. They needed waves not in meters, but in centimeters. This was the holy grail of radar technology. Microwave radar. A 10-centimeter wavelength could, in theory, be focused into a pencil-thin beam by a small parabolic dish just a few feet across. A dish small enough to fit in the nose of a bomber or on the mast of a destroyer. A radar set using these centimetric waves would be a revolution. It could spot the periscope of a U-boat. It could see the shape of a coastline through solid fog. It could, even, perhaps, be made small enough to guide a bomb directly onto a target. The problem was power. Everyone knew how to make centimetric waves. A device called a klystron tube could do it, but klystrons were incredibly weak, producing only a few watts of power. It was enough for a lab experiment. But to get a useful radar echo from miles away, you needed kilowatts, thousands of watts. The German scientists, brilliant as they were, had looked at this problem and declared it unsolvable for the foreseeable future. They told their high command that microwave radar was a fantasy, not practical for this war. And so, they focused their efforts on refining their existing meter-wave radars, like the SeaTac and Freya. This was, perhaps, the single greatest mistake they made.
Because in Britain, a small team at Birmingham University, working under the pressure of imminent invasion, did not give up. Two men, John Randall and Harry Boot, were tasked with finding a solution. They were, in the classic British tradition, brilliant, eccentric, and perpetually underfunded. They worked in a drafty, cold lab with cobbled-together equipment. They revisited the klystron, but they had a different idea. Instead of a linear tube, what if they used a resonant cavity? What if they created a block of copper with precisely machined holes in chambers, a device that would cause electrons to, in essence, resonate, like a whistle, but at an incredibly high frequency? They took a solid cylinder of copper, drilled holes in it, and combined it with powerful magnets. They called it the cavity magnetron. In February of 1940, they turned it on for the first time. The power output was so high, it nearly melted their test equipment. It was producing not just watts, but kilowatts of power. On a 10-centimeter wavelength, it was the impossible made real. It was a piece of technology no bigger than a shoebox that held the power to change the world. The British government immediately classified it as the most important secret of the war, even more secret than the efforts to crack Enigma. They knew instantly what this meant. But Britain in 1940 was on its knees. France had fallen. The Battle of Britain was raging. The Blitz was beginning. They had the invention, but they lacked the industrial might to mass produce it and build the thousands of radar sets needed to win the war. They had only one true powerful ally left, even if that ally was still technically neutral, the United States. In the late summer of 1940, a quiet, unassuming delegation of British scientists led by Sir Henry Tizard boarded a ship for America. With them, they carried a single, locked black box. The contents of this box, they were told, were to be shared with their American counterparts. This was the Tizard Mission. When they arrived in Washington, D.C., they met with America's top scientists. The Americans showed them what they were working on, good, solid research, but on parallel tracks to the British. Then the Tizard Mission opened their black box. Inside, sitting on a velvet cushion, was the cavity magnetron. The American scientists were stunned. They were, frankly, in disbelief. They had been working on the same problem and were stuck at the same 10-watt barrier. This British device, this tiny copper block, was claiming to produce 10,000 watts. It was a quantum leap. It was, as one American scientist later put it, like finding a $1 million bill in a dime store wallet. The Americans immediately understood its importance. A new laboratory was formed almost overnight at the Massachusetts Institute of Technology, or the MIT Radiation Laboratory, or simply the Rad Lab. This unassuming building would soon become the epicenter of the Allied technological war effort, the counterpart to the code breakers at Bletchley Park and the bomb makers at Los Alamos. The Rad Lab's mission was simple: take the British laboratory prototype and turn it into a weapon of war. A rugged, reliable, mass-producible radar set that could be bolted into a plane, tossed around on a destroyer, and operated by a 20-year-old technician under combat conditions. The greatest minds in American physics, engineering, and manufacturing flocked to the Rad Lab. They worked 20-hour days, fueled by coffee and a sense of profound urgency. They refined the magnetron, designed the new receivers, the parabolic dishes, the glowing cathode ray tube displays, and they did it with breathtaking speed. We cover these hidden stories of ingenuity every week. If that's something you find valuable, taking a moment to subscribe really does help us keep this history alive. Within a year, the first production line Centimetric radar sets were rolling off assembly lines in America and Britain. The first priority was Coastal Command. The new radar, called ASV Mark III, was installed in Liberators and Sunderland flying boats. These planes now had an eye that the Germans knew nothing about. It operated on a 10-centimeter wavelength, a frequency that the German Mettox receiver could not hear. The U-boat, once the hunter, was about to become the hunted. And its crews, still laughing about the magic eye, were sailing into a trap. The change was not instantaneous. It took time to build the sets, install them, and train the crews. But by late 1942, the new radar-equipped planes were reaching the Atlantic in significant numbers, and the U-boat crews were the first to feel the difference. They were diving, as they had always done, when their Mettox receivers beeped. But something was wrong. Sometimes there was no beep, just the sudden, terrifying roar of aircraft engines overhead and the colossal splashes of depth charges erupting around their hull. Survivors, if there were any, would report being attacked out of a clear black night with no warning whatsoever. A new, terrifying rumor began to spread through the U-boat fleet. The Allies had a new weapon, one that was truly invisible. This new radar was devastating, but it still had one small weakness. The radar beam itself was a cone. As the aircraft got very close to the U-boat directly overhead, the U-boat would fall into the blind spot at the cone's center. The radar contact would vanish just in the last critical moments of the attack. In the daytime, this didn't matter. The pilot could see the U-boat visually. But at night, the U-boat could slip away in those final seconds. The solution was another simple, brilliant British invention, the Lee light. This was an enormously powerful 22 million candela searchlight mounted under the wing of the aircraft and synced with the new radar. The radar operator would guide the pilot toward the unseen target. Then, at the last mile, when the blip was about to disappear, he would flip a switch. The Lee light would blaze on, instantly illuminating the surfaced U-boat in a terrifying, inescapable bath of white light. The U-boat, caught like a rabbit in the headlights, had no time to dive. The pilot, now able to see his target clearly, would release his depth charges with lethal accuracy.
The combination of centimetric radar and the Lee light was a killer. The U-boats, which had once owned the night, were now terrified of it. The Bay of Biscay, the U-boats' transit route from their bases in France to the open Atlantic, became a killing ground. The Germans called it the Black Pit. They tried to fight back. They tried surfacing in groups, arming their U-boats with more anti-aircraft guns, turning their submarines into flak traps. It was a disaster. The heavily armed Allied aircraft would sweep in, cannons and rockets blazing, and tear the surfaced boats to pieces. The U-boats had lost their invisibility, and with it, they had lost their only real advantage. But the revolution wasn't just happening in the air, it was happening on the sea. This brings us to the destroyers. The title of this video promises destroyers hunting U-boats, and that is exactly what began to happen, with an efficiency that broke the back of the U-boat arm. The new Centimetric radar sets, with their small rotating dish antennas, were perfect for shipboard use. They were mounted on the masts of the new destroyer escorts and corvettes. These ships were no longer blind at night. Their new radar, often called Type 271, could pick up the tiny, exposed conning tower of a U-boat from miles away, long before any human lookout could. The hunter-killer groups, led by brilliant anti-submarine commanders like Britain's Captain Frederick Johnny Walker, now had the tool they needed to turn the tables. Walker's strategy was relentless. His group of ships, usually 6 sloops or destroyers, would work as a team. One ship would get a radar contact. But they wouldn't just charge in, they would use their other secret weapon, high-frequency direction finding, or Huff-Duff. This system could detect the short radio transmissions from the U-boats as they reported the convoy's position. Huff-Duff could give a precise bearing to the transmitting U-boat. So Walker ships would get a radar contact and a Huff-Duff bearing, confirming the target. Then the hunt would begin. 2 ships would be detached to pursue the U-boat, while the rest stayed with the precious convoy. The destroyers would close in, their radar guiding them through the darkness. The U-boat, with his Metox receiver silent, would have no idea they were coming until the destroyers were almost on top of him. He would crash dive, but it was too late. The destroyers had his exact position. They would race over the swirl of water left by the diving sub, and the Aztec operators would take over, their pings locking on to the submerged steel hull. And now they had another new weapon, the Hedgehog. Before, destroyers had to drop depth charges, barrels of explosives that had to be set to a certain depth and dropped behind the ship. This meant that in the final moments of the attack, the Aztec would lose contact as the ship passed over the sub. The Hedgehog, however, was a forward-throwing mortar. It fired a pattern of 24 small, contact-fused bombs ahead of the ship. The Aztec operator could hold the contact, the ship could fire the Hedgehog, and the bombs would arc through the air, landing in a deadly circle around the U-boat's predicted position. They only exploded on contact, which was not only more lethal, but also more psychologically terrifying. If the crew heard no explosions, they were safe. If they heard one, it meant the hull had been breached, and they were dying. This combination, Centimetric radar to find them on the surface, Huff-Duff to confirm, Aztec to track them, and Hedgehog to kill them, was unbreakable. The wolfpack, once a coordinated group of hunters, was shattered. They were now the hunted, picked off one by one, relentlessly in the dark. The German Admiralty was in a state of blind panic.
Their crews were reporting invisible, undetectable attacks. They couldn't understand what had happened. Their scientists, the ones who had declared centimetric radar impossible, were baffled. They scrambled to find a solution. They developed new radar detectors, Naxos and Wannsee, designed to pick up the 10-centimeter waves. But these were rushed into service. They were unreliable, and their range was poor. Often they would only give a warning when the Allied plane was already in its final attack dive, far too late.
The breaking point came in a single catastrophic month, May 1943, known forever after in German naval history as Black May. In that 1 month, the Allies had perfected their tactics. Their new radar sets were everywhere. Their hunter-killer groups, led by men like Walker, were operating with ruthless efficiency. And the U-boat fleet, sent out to find the convoys, sailed into a buzzsaw. In May 1943 alone, Admiral Donitz lost 41 U-boats, nearly a quarter of his entire operational force. Thousands of experienced crewmen, the best in the German Navy, were lost with them. The convoy losses in return dropped to almost nothing. The trade was no longer sustainable. It was suicide. At the end of the month, a stunned and grieving Donitz, who had lost his own son in the battle, recalled his U-boats from the North Atlantic. He wrote in his war diary, "We have lost the Battle of the Atlantic." He was right. The Centimetric wave had done what no battleship or army could. It had saved Britain. The story doesn't quite end there, of course. The Germans, in their desperation, tried to innovate. They developed the acoustic homing torpedo, the GNAT, which would listen for the sound of a destroyer's propellers. The Allies countered by developing a noise-making decoy, Foxer, that they towed behind their ships. The Germans developed the Schnorkel, a breathing tube that allowed U-boats to run their diesel engines while submerged, making them true submarines instead of just submersibles. This made them much harder to detect by radar. But these innovations came too late. The tide had turned, and it would never turn back. The sheer number of Allied ships and planes, all equipped with the magic 10-centimeter radar, was overwhelming. The supply lines were secure. The buildup for D-Day, the invasion of Europe, could begin. And it was all thanks to that small copper block from Birmingham. It's truly staggering to think about the what if. What if Randling Boot had failed? What if the Tizard mission had been sunk by a U-boat on its way to America? Without the cavity magnetron, there would be no effective air-to-surface radar. The wolfpacks would have continued their happy time. Britain, starved of fuel, food, and steel, would have been forced to negotiate a peace with Hitler. The United States would have lost its unsinkable aircraft carrier in Europe. D-Day, the liberation of France, would have been impossible. The world we live in today would be unrecognizably different. The entire course of human history was changed by a single, brilliant invention, born of desperation, and shared in a moment of extraordinary trust between allies. And the legacy of that invention? It's probably sitting in your kitchen right now. After the war, an engineer at the Raytheon Company named Percy Spencer was working on a magnetron set. He was, as the story goes, a man who loved to tinker, and he happened to have a chocolate bar in his pocket. He stood in front of the active magnetron for a moment, and when he reached for his snack, he found it had completely melted. He was curious. He tried another experiment with popcorn kernels. They exploded all over the lab. The next with an egg, which cooked so fast it exploded in his colleague's face. Spencer and Raytheon realized what they had, a revolutionary way to cook food using the very same centimetric microwaves that had once hunted U-boats in the dark. They called their first commercial product the Radar Range. Today, we just call it a microwave oven. It's a story that's often overlooked, and we're curious, did you know the microwave oven came from this secret radar war? Let us know in the comments below. It helps us figure out which stories to tell next. It's a strange but powerful thought. The same technology that sent thousands of men to the bottom of the ocean in a brutal fight for survival now quietly heats our leftovers. It's a reminder that war, for all its horror, is often the most powerful engine of innovation. The men who fought and died in the Atlantic, on both sides, were caught in a technological vice. The U-boat crews who began the war with such arrogance, mocking the magic eye, ended it in terror, hunted by an invisible force they couldn't understand until it was too late. Their fatal mistake was one of hubris. They believed they had solved the problem, that their Metox receiver was the final answer. The German High Command, in its arrogance, failed to fund the very research that could have given them the centimetric advantage. The Allies, on the other hand, were desperate. And desperation, it turns out, is the mother of invention. They never stopped believing their technology could be beaten, so they never stopped working to create the next thing. They took a laboratory miracle, scaled it with American industrial power, and deployed it with brilliant, relentless tactics. They turned the tables, completely and irrevocably. The story of centimetric radar is the story of the Wizard War, a quiet, secret battle fought by scientists in white lab coats whose victories were measured in kilowatts and wavelengths, but which ultimately saved the lives of millions and secured the freedom of the world. It proves that sometimes the most powerful weapon isn't the one that makes the loudest bang, but the one that allows you to see in the dark. We know that was a long journey, but it's a story that deserved to be told in full. If you found this history as fascinating as we do, the best way to support the channel is to share this video with one other person who appreciates these stories. We believe these moments of history, where ingenuity and courage changed the world, should never be forgotten. If you want to see the other secret weapon that changed the air war over Europe, we've teed up our video on the P-51 Mustang for you next. Thank you for watching.